Welcome to the engineering video series. This tutorial introduces how to develop add-in functions for any type of analysis in the GeoStudio product suite, which empowers users to customize their GeoStudio experience and optimize their analyses, providing you with greater control and flexibility in your geotechnical modeling and analysis projects. This tutorial is based on materials provided in the GeoStudio Add-in Software Developers Kit found in the resources of the Sequent Learning Center. Let's start by reviewing a few terms related to the development of computer programs. In computer programming, a field is a variable. A method is a set of operations that fulfill a particular objective. A parameter, or an argument, is a value passed between methods. The method passing the value is referred to as the calling method. A class is a declaration of what a specific instance of the class can do. A class has both properties and behaviors which are defined by the included field and methods. An individual instance of a class is called an object. An example of an object is a boundary condition applied to a specific node at a specific time. Now that we've reviewed these terms, let's consider what an add-in function is. In general, an add-in function is a user-defined relationship. This relationship may follow the form y is equal to f of x, where the value of y is determined based on the value of x given the add-in function f. An add-in function can be used in place of an internal GeoStudio function. Internal GeoStudio functions include material property functions and boundary condition functions. Add-ins are incorporated in any GeoStudio analysis as a supplemental function run by the solver. Add-ins allow users to integrate specialized models, boundary conditions, material functions, and customize workflows into GeoStudio that are tailored to unique project needs. Boundary condition functions are applied to geometry items, such as points or lines. An example of an add-in function that could be developed for a boundary condition is a function specifying the total head in a reservoir that changes with time over the simulated period. Material properties functions are applied to regions. An alternative material function can be implemented with an add-in function if the simulated soil exhibits changing strength over time or distance. An add-in function can also replace the existing constitutive models for stress-strain relationships in sigma W. The add-in is called by a method within the GeoStudio solver. First, the GeoStudio solver automatically passes the x value to the add-in. This is the parameter or argument being passed into the method. The add-in may also request more data from the solver about its current context, such as the current elevation being solved for. With this information, the add-in function determines y and returns it to the solver. Note that the data type of the x and y variables depends on the GeoStudio function that the add-in is replacing. An add-in function follows the general format illustrated on the right. The key elements of an add-in are the name of the add-in or declaration of a class, the method or function of the add-in, which must be called calculate and is the portion of the code that determines the value of y based on the inputs, and a return command, which can be used to send the y variable back to the GeoStudio solver. Both the class and the calculation method must be public in order for the GeoStudio solver to see them when scanning an add-in. When a variable name or field is declared as public, this field will appear in the GeoStudio Define view under Key-in Functions. An add-in function can be written in any common language runtime coding language like F#, C#, and C++. The generated code must be converted to the appropriate format in order to be called by GeoStudio. A computer language compiler is used for this conversion. A compiler is a computer program that transforms source code written in the source language into another computer language called the target language. Compiled code containing an add-in function is called an assembly. The assembly is stored in a dynamic link library file, or DLL file, which is in the machine language. We strongly recommend using an integrated development environment for writing, debugging, and compiling the add-in code. Let us now review the process of developing custom add-ins for GeoStudio with step-by-step instructions for setting up and using Visual Studio to create, debug, and test add-ins. Visual Studio is used in the demonstration as it provides a robust environment for writing, debugging, and managing C# code that powers the add-in. Through Visual Studio, one can develop, test, and debug the add-in libraries, ensuring that the custom features are properly integrated and functioning as expected. The built-in debugging tools, such as breakpoints and step-through debugging, allow users to closely monitor how their add-in interacts with GeoStudio, helping to identify and resolve issues quickly. If you do not have Visual Studio, the Community Edition can be downloaded for free. As mentioned, this demonstration will focus on using Visual Studio for creating add-ins. After downloading and installing Visual Studio, we must configure the installation settings. You can do so by opening Visual Studio Installer and selecting Modify to customize the installed components. In the Workloads tab, check .NET Desktop Development to include essential tools for .NET applications. In the Individual Components tab, ensure that the .NET Framework 4.8 SDK and .NET Framework 4.8 Targeting Pack are both installed. To apply these changes, click Modify or Install if setting up Visual Studio for the first time. Once the installation is finished, you may need to restart your computer if prompted. We can now open Visual Studio to ensure it launches without errors. You can confirm that the correct components were installed by going to Help, About Microsoft Visual Studio. Let us create a new C# project in Visual Studio to develop our GeoStudio add-in. Go to File, New, and select the Project option. In the Create a New Project dialog, type Class Library, .NET Framework in the search bar. From the search results, select Class Library, .NET Framework, to create a C# class library. The generated class library will serve as the foundation for writing custom functions and features that can be integrated into GeoStudio. Then select Next to proceed. In the Project Name field, provide a name for your add-in project. You will need to specify the location where the project will be saved. Ensure it is a directory you can easily access. In the Framework dropdown, choose .NET Framework 4.8. Once the configuration is complete, click Create to finalize the creation of your C# class library project. By selecting the appropriate project type, you ensure that the generated code is compatible with GeoStudio. Once your new C# project is created, you will need to set it up for development by organizing your files. After creating the project, Visual Studio automatically generates a solution and a project. The class1.cs file will open by default. To view the Solution Explorer, go to View Solution Explorer from the top menu. Here you can see the project's files and structure. You can rename the class file in the Solution Explorer by right-clicking on class1.cs and selecting Rename. Here you can add a more meaningful name for the file to better reflect the purpose of the .cs file. Instead of creating a new C# project, you can also import an existing GeoStudio add-in C# file to use as a template for your project. These pre-written CS files are stored in the Resources tab on the Sequent Learning Center in the GeoStudio Add-ins Software Development Kit, which is available to download. Once downloaded, extract the contents of the zip file to a convenient location on your computer, such as your project directory or a dedicated folder for add-ins development. Using a text editor, open the desired CS file from the extracted add-ins kit. For example, open the file Slip Surface Strength. I can copy the entire content of the open file, return to the CS file generated in Visual Studio, and paste the copied content into that file. This replaces the default class code with the content from the GeoStudio add-in sample. Now I will build the solution in Visual Studio, which is crucial for compiling the project and generating the DLL file that GeoStudio will use as an add-in. By building the solution in Visual Studio, you ensure that the code is correctly compiled and any external references, such as necessary GeoStudio libraries, are properly linked. We will start by referencing the required DLL file in this project in order to use external classes and functions. In Solution Explorer, right-click on References under your project tree. Then select Add Reference from the context menu. In the Reference Manager window, click on the Browse button on the bottom. Navigate to the GeoStudio installation directory, which by default is located in the C drive under Program Files, Sequent. Here you will find the GeoStudio version you are currently using. In the bin folder, select the gsi.mngsrv.dll file from the directory, and then click Add. This will add the required reference to your project. Let us now compile the project and generate the output by going to the Build menu at the top of Visual Studio and selecting Build Solution. This triggers the build process and generates the output based on your current project settings. After the build process completes, we can verify the build results by opening the output window in Visual Studio. If the build is successful, the output will display the path to the generated .dll file. In this case, myaddins.dll, confirming that the build was completed without errors. We will now configure GeoStudio to recognize the newly created add-in by specifying the location of the DLL file. This is essential for integrating your custom functionality into GeoStudio. To do so, launch GeoStudio from the Start menu or desktop shortcut. Once GeoStudio is open, navigate to Edit, Options in the top menu. In the Options window, we can configure various settings. We will set the add-in directory by going to Folders, Add-in folder. Here I will click on Browse and select the folder where the file myaddins.dll was generated. Note that you can find this directory in the Output window of Visual Studio after a successful build, as we previously demonstrated. After selecting the correct directory, click OK to save the settings. GeoStudio will now recognize your myaddins.dll file as an available add-in for use in analyses. Let us now apply and test the newly created add-in by using it in a GeoStudio project. This example involves defining a new material that utilizes the add-in function, assigning it to a soil layer, and running both the original and modified analyses for comparison. The purpose of this comparison is to benchmark and verify the intended functionality of the add-in. I will open a SlopeW project. In this case, I'm using one of our verification examples. In the Project Explorer, we can clone an existing analysis by right-clicking on it and selecting Add Analysis, Clone Analysis. I will define a new material, which will use the add-in function by navigating to the Define Materials dialog and selecting Add. I will set its type to shear normal function. Under the shear normal strength function, I will click the ellipses button to open the Define Shear Normal Strength Functions window. Add a new function and set the function type to Add-in function. In the Add-in field, I will click Select. Choose the myaddins.dll library from the pop-up list and select OK. In the Model field, I will select one of the available models and enter the required parameters based on the analysis specifications. Back in the Define Materials dialog, I will select the shear normal function that I just set up. Now I will assign this new material to the topsoil layer in the duplicated analysis. To verify that the add-in was properly used, I will solve both analyses and compare the results. In this case, identical properties were specified for both the Moore-Coulomb and add-in function material models. The analyses yield the same results, confirming the add-in's correct implementation. In summary, add-in functions can replace internal GeoStudio functions, allowing for greater flexibility for specifying material behavior and boundary conditions, particularly when the material or boundary condition varies dynamically with the analysis state. Add-in functions can range in complexity from very simple to highly involved functions. Add-ins can be written in any CLR language. However, we suggest using an integrated development environment like Visual Studio for writing, debugging, and compiling the add-in code. The developed add-in functions are accessible from any GeoStudio analysis when they are placed in the specified directory as demonstrated in this video. Note that not all the powerful capabilities of add-in functions have been discussed in this tutorial. Please see the Add-in Software Development Kit available in the Scikit-Learning Center for more information.